Right, here we go for question 2 of the Calculus 2020 exam. We're going to do the achieved and merit questions, so let's see how we get on with this. Okay, we've got a function here, and we are asked to describe the gradient function. So let's look at the gradient. So I'm going to take a couple of points on the line and see if I can find where they cross a corner. Here's one, it crosses a grid here. And it crosses a grid here, and it crosses a point of a grid there. So if we count upwards 1, 2, 3, 4 along 1, it has a gradient of 4. Same here, it goes along 4 up 1, and again along 1, 2, 3, 4. So it's got a gradient of 4 here, it's got a gradient of 4 here, and it's got a gradient of 4 here. So that means that I have to have a gradient of 4 here, and a gradient of 4 here, and a gradient of 4 here. In fact, a whole line, and I need to plot these points along the line and use a ruler. My ruler function is not working at the moment. It's my excuse, I'm sticking to it. Okay, so the next one. Mariana has developed influenza, wants to stay away from work, etc. She wants to know about aspirin and Panadol, and she's got these two equations. She wants to reduce her fever. Okay, we're going to use calculus. If you're going to reduce your fever, you're looking at a rate of change. So we're going to do aspirin first, and we're going to do the rate of change for aspirin. So we're going to differentiate according to H. That will disappear. That will come to negative 0.02, and this will come to, when you multiply by the power, negative 0.1 H. And then we're going to do the same for Panadol. So here's our Panadol 1. And when we differentiate this, that comes to negative 0.03. And 2 fourths negative 0.08. So this one has a steeper gradient than this one here. So the aspirin will be more effective because of the gradient that is steeper. So aspirin is more effective because the gradient is steeper. So there we have it, and that will give you an achieved mark. Right, after how many hours would Mariana's temperature be decreasing at a rate of 0.05 degrees Celsius if she used Panadol? Well, we've got the rate of change for Panadol is negative 0.03 minus 0.08H. It's a rate of change, and it's decreasing at 0.05. So then we solve that by putting the 0.03 to the other side, add it to that, and you will then divide by negative 0.08. So that will give you negative 1. And so you'll see that that is quite incorrect there. What have I done? 0.08. Oh, I know why. It's decreasing at a rate of negative 0.05. So that was a slight error there. So that means that there is negative 0.05 plus 0.03, which is negative 0.02. And when you do negative 0.02 divided by negative 0.08, that will give you H equals 1/4, 0.25 hours. 25 hours is 15 minutes. So after 15 minutes, you'll find that it will be decreasing at a rate of 0.05 degrees Celsius per hour. It takes 15 minutes. So the next one, the rate of change with respect to time, and Mariana's temperature is 37 point. If she takes calculate the rate of change, if she takes the aspirin medication. So the temperature has to be 37.5. So let's go to this one here. She takes the aspirin. So we go to the aspirin one, which is this blue one here, negative 0.02. So we've got negative 0.02 minus negative 0.02 minus. So that's the rate of change. However, we need to go to the whole formula, temperature formula. So if we copy out the temperature formula for aspirin, it is 38 minus 0.02H minus 0.05H squared. We need to find when it is 37.5 degrees. So we put 37.5 degrees for our temperature. So that's the starting point. I didn't actually need the rate of change at this time. And then we take the 37.5, put it to the other side, and it is 0.5, not 0.05. We're going to have to solve this equation. Now you can do this on your calculator or using the quadratic formula or try and factorize it, but you'll get H equals 2.9685. That's hours. Ignore the negative value because you don't have a negative time. If you're using the quadratic formula, A equals negative 0.05. Same for your calculator. B equals negative 0.02 and C equals 0.5. Put those in to get that. Now we have to put that in terms of minutes there. Do we calculate the rate of change with respect to time in hours? So that's 2.95 hours. I suppose that's all right. But if you wanted to change that to minutes, multiply 0.9685 by 60 minutes, and that will give you 58 minutes. So it's almost 3 hours would be the time. We now read the question again. We want the rate of change when it's there. So the rate of change is this one here. So we're going to use our top formula now. And the rate of change, which will be T dash, and I'll just do this in black, T dash, because that's our rate of change, is negative 0.02 minus 0.1 times the hours, and we're going to do the hours as a decimal, 2.9685. Calculate that on your calculator, and hopefully you should get that it's dropping at a rate of 0.317 degrees. 0.317 degrees per hour. That's the rate that it is dropping. Cool. For your merit. Hope that was all good.